Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. Occasionally I get requests from viewers to do videos on a particular topic. Today's topic is a request from Ronbo Prime to do a video on saving a character to a file with JSON, maintaining cohesion and coupling. Ronbo Prime, I hope this video helps you and others. Please feel free to comment with follow-up questions. Saving is an obviously important part of any game. Saving means taking the game state, which is stored in variables in temporary memory as the program runs, and storing it in some form on permanent media, such as a hard drive. And of course, saving is no good without restoring. Your program needs to be able to read the stored game off of the permanent media and into variables, so the program can pick up exactly where you left off when you saved. I do have a video on saving program state with the pickle library in Python, which I will link here. That's one way you can save and restore program data. But let's look at a JSON solution using Python's JSON library. By the way, how do you pronounce JSON? It's supposed to be pronounced like the name Jason, but I've never heard anybody say it that way. If that's how you pronounce it, I apologize in advance for saying JSON throughout the video. You can turn the sound off and read the captions to preserve your sanity. A JSON file is a text file, so it's human readable. This is the example from Wikipedia, and you can see it looks a lot like Python dictionaries and lists, and closed in curly braces like a Python dictionary, and then name-value pairs, first name, a string, colon, and then the value, John, a string. Notice that some of the data is string data like first name and last name. There's a Boolean value here, is alive, and there's an integer value, age. There are some lists, phone numbers, and children. There's also a null value. And this is roughly how we'll take data in Python and turn it into a JSON file. We'll store the data as a dictionary and write it out or read it in using Python's JSON library. So if you can organize the data you want to store as a Python dictionary, you can store and retrieve it in JSON format. Let's look at a simple example. This file is called simpleexample.py. And as always, this is available in my GitHub repository. There's a link in the description. Now we have a very small and simple class called character. An object of class character has three fields: name, a string, and charisma and strength, both integers. There's an init method, which initializes these fields from parameters. There are two methods after the init, one for storing the object as a JSON and one for creating an object from a JSON. Let's jump over those for just a moment. The last method of the character class is str, which returns a string version of the object suitable for printing. Let's look at the main function. The main function creates a character object by calling the function createCharacter, which simply asks the user for the name, charisma, and strength values, and then instantiates a character object and returns it. We then print that character and save the character out to a file called character.json. And then we read in from character.json and create a separate character object from that, simply to illustrate that when we read in, we are creating a new object from the data in the file. And we print that. I'll run it once, and then we'll take a look at how the JSON functions work. Okay, the program prompts me for the character's name. In some of my Java videos, I have a character called R2 the Barbarian, so I'm going to type that. And R2 has charisma and strength of 18. The program says, you just created the following character, and it shows me the information I just typed. And then it says, I just read this character from the file character.json, and it's the same information. Let's look at the JSON code closely now. Our goals in writing the character to a file, as expressed by Ronbo Prime, are to maintain cohesion and low coupling, which I interpret in this context to mean objects are responsible for saving their own data, and changes to one object will not impact others. So in other words, you might have a character with an inventory that all gets saved and restored, but changes to the way the inventory works will have no impact on how the character saves itself. and changes to how the character works will have no impact on how the inventory saves itself. And this is relatively easy with object-oriented design. Objects have responsibilities, and in order to fulfill those responsibilities, we give them data and operations on that data. So a character has so far just the responsibility to return a string description of itself, but also to write itself to a JSON string and basically reconstitute itself from a JSON string. In terms of cohesion, this means that all operations that relate to the object's data are part of the object or class. In terms of low coupling, it means that no other object in the system is tangled up in some way with character. So in main, we create a character object called character write on line 60. That's the one the user is giving us the data for. When I ran the program, that was R2 the barbarian. On line 65, I open a file called character.json in write mode, and then I write to it. What I write is the result of the call character_write.toJSON. Let's take a look at toJSON up in character. Okay, on lines 23 to 27, a few things are going on. Let's work this from the inside out. On the inside, we're making a dictionary version of our character object. Remember that a dictionary is a set of key value pairs. So at the simplest level, like what I have here, that's a key for each field of the object. And the values are the values stored in the fields. So we have the key name, and the value is self.name. In our example, R2 the barbarian. And then we have two more key value pairs for the charisma and strength fields. That's a dictionary. You can tell by the curly braces and the key value pairs. Now a few things to understand. First, the keys are always going to be strings. If you create a key that isn't a string, it will be changed to a string. Second, there are only certain data types that we can dump directly into a JSON format using the JSON library, as we're doing here. We can dump string, int, bool, float, and none. And we can also dump some collection types, dict, list, and tuple. Okay, so working outward on line 23, we're passing that dictionary to json.dump_s. That's dump s, s for string. That returns a JSON string. Let's do a couple of examples in the console. Hopefully JSON is still available as a name. If it isn't for you, import JSON before you try these commands. So I'll write json.dump_s, open paren. Now I'm going to make a dictionary, so open curly brace. And then let's say we're doing something like coordinates for a drawing. I'll write location. Remember, keys are strings. And let's try a tuple. So colon, and then in parentheses 100, close paren, comma. Okay, and let's have size, colon 50, close curly brace, close parentheses, enter. And that returns a JSON string, which looks a lot like my dictionary, except the location delimiters are square brackets. Let's do one more. I'm going to write json.dump_s, and then open paren, open curly brace, but I'm going to copy what I had before, the whole dictionary. And then for a key, square, colon, and paste what I had, comma, and then I'll do circle, colon, and I'll paste in the same thing and maybe make it larger. I'll put size 100. And then I'll close my dictionary and my call to dump s and press enter. And you can see that works. So this nesting, putting a dictionary within a dictionary, is how we're going to be able to use JSON to save more complicated objects. Okay, now that we've seen that and played with it a little, let's go back to our program. So json.dump_s returns a string like the ones we just saw, a JSON string, and that is returned by to JSON. And back in main, that's written to the file character.json. Let's go take a look at that file. The nice thing about JSON files, or maybe not nice, depending on whether you want users to be able to change save files, is that the file is text, human readable. Here it is in the directory with the program, character.json. I'll open it in Notepad++. And you can see the R2, the barbarian string. Hopefully that is what you expected. Now back in the program, we then open the file for reading, and we create a character, a new one, from the first line of the file. So you can see I'm passing the result of f.read, reading a line from the file, to character.fromJSON. Notice anything about that? I'm sending the message to the class, character, not to a specific object of the class. This is an implementation of the factory method pattern described in the book Design Patterns. I'll include a link in the description. We can't overload the initializer method in Python. So for example, in another object-oriented language such as Java, we'd be able to write a constructor that takes a JSON string as a parameter. We'd have two constructors, one that takes the 3 parameters like we have here in the initializer, and one that takes a JSON string. But we can't do that. So we have a static method, meaning we invoke it on the class, not a specific instance. And that method is going to return an object of the class. So let's look at it. And it has a decorator at static method. It takes as a parameter the JSON string, what we read from the file. And it sends that to json.loads, load string. That returns a Python dictionary. Let's look at loads in the console. Let's say character dictionary equals json.loads, and we'll pass in the R2, the barbarian JSON string. And if we look at character dictionary, it certainly looks like a Python dictionary. If I type character dictionary, the console tells me it's a dictionary. So loads takes a JSON string and returns a Python dictionary. We can then pull the values out of that dictionary using the keys and pass them to the initializer by creating a character object. We then return that from the fromJSON method. Okay, this video is already a little bit long, so I'm going to stop here and we'll look at a more complicated example next week. I will probably already have recorded that video by the time you're commenting on this one, so if I can't address your questions in the next video, I'll either address them in the comments or I'll make a third video on this topic. So please do ask questions if you have them. One way or another, I'll get to them. I hope that so far this is helpful, and I look forward to bringing you a more complicated example next week. As always, have fun and keep coding.